Hi, this little video is going to take you through some of the index laws. This is the topic that you did last year in the ECP, and this topic will be on the end of semester examination. So it's a pretty good idea to run through this and make sure that you remember all of these rules. This is topic 6 in the textbook, and it goes through the different index laws 1 and 2, index law number 3 in the zero index laws 4 and 5, and then we'll have a look at negative indices. So index laws 1 and 2 are here on this slide for you to have a look at. Index law number 1 is this one here, and it tells you that if you have a to the power of m times a to the power of n, that you can simplify that by simply adding the indices here. So by adding the indices and keeping the base the same, you'll be able to simplify two index expressions that are multiplied together. And it says it here in words. When multiplying terms, with the same base, we add the powers. Index law number 2 deals with how you simplify things that are divided. So a to the m divided by a to the n simplifies to a to the m minus n. So here, when we are dividing index expressions with the same base, we keep the base the same and we subtract the powers. And they're the two things you need to remember for these index laws. Now we're going to go through a couple of examples. So here, the first example we've got here, 3 to the power of 6 times 3 to the power of 4. Now, we can use the index laws to simplify this expression because these bases here are the same number. It's really important that you make sure that the bases are the same. And then the rule tells you that you keep the base the same and you just simply add these indices together. So this would simplify to 3 to the power of 10. This one is very similar, but this time we're being asked to divide these expressions. So we've got 7 to the power of 9, which is just 7 times 7 times 7 times 7, 9 times. And we're dividing it by 7 to the power of 5. So we know that another way you could write this is just 7 to the 9 divided by 7 to the 5. We keep the base the same, and all we need to do now is just subtract the indices. So 9 minus 5, and that would give us 7 to the power of 4. So there's two straightforward examples about using the first and second index law. These examples get a little bit more complicated, but they're still all along the same lines. If we were trying to simplify this, we'd look at it, we'd go, yep, base is the same, so we can simplify it. We're going to keep the base as x, and we've got a 4 here and a 5 here. Index law number 1 tells us that we can just add those up to get x to the power of 9. This example, we have x to the power of 3 times y to the power of 4 times x squared times y. Now this is all multiplication here, so we're just going to look at the x's and times them together. So we've got x cubed times x squared. We keep the base the same and we add the indices to get 3 plus 2, which is 5. And then the y's, we've got y to the power of 4 times y to the power of, and there's an unwritten little 1 up here. We keep the base the same as y, and we add those powers together to get y to the power of 5. And we just leave it like that. There's an unwritten times sign in here that you don't need to show. This one also has numbers in it. So the first thing we do is deal with the numbers. And remember, this is all times. So 3 times 2 gives me 6. And m to the power of 4 times m to the power of 5. We keep the base the same and we add the indices together to get 6m to the power of 9. Good, let's keep going. Here's another couple that we can work through. So this one says we have x to the power of 10 divided by x to the 2. So you just need to remember that that could also be written as x to the 10 divided by x to the 2. Now we can use the second index law, keep the base the same, and just subtract the powers. 10 minus 2 is 8. This one looks very complicated, but if we just work through it carefully, it won't be so bad. The first thing we do is we look at the numbers and we say, okay, well, we can't really divide, 8 divided by 12. We can't really actually work that out, but we can simplify it a little bit. It's like this is a fraction by itself, 8 divided by 12. So first of all, we are just going to say 4 will go into 8 and 4 will go into 8 twice, and 4 will also divide into 12 3 times. So when we simplify the numbers, we've left with a 2 on the top, and we're left with a 3 down the bottom here to start off with. Then we look at the a's and we say we've got a to the 6th divided by a squared. So we're going to simplify that using the second index law. We keep the a and we just subtract the powers. 6 take away 2 gives me 4. And the same with the b's. B to the power of 3 divided by b to the power of 2. We keep the b and we subtract 3, take away 2 is 1. And you can put the 1 there, but you don't need to. It's understood that there's a 1 there. And that's the answer. 2a to the power of 4 over b divided by 3. So as long as you do it systematically, deal with the numbers first by cancelling. So in this case, we cancel the numbers down by looking for any common factors that they have, and then we use the first and second index laws to simplify. And that's easy. Good. Now we're going to have a look at a few harder examples here that pretty much deal with exactly the same thing. So if we scroll up, we can see the first example. This one is asking us to work out x squared times x cubed divided by x to the 4. And you can do this in 2 steps if you like. This is really, if we rewrite it, it's x squared times x cubed divided by x to the 4. That's what that means. So I always like to simplify the numerator first. This would become x. We're going to use index law number 1 and add the indices. X to the 5 over x to the 4. And then we use index law number 2, keep the base the same, and just subtract the powers. 5 take away 4 is 1. You don't need to write it in this case. And the answer is just x. Let's have a look at this one. Now again, we'll go through and we'll see if we can simplify the numerator first. We've got 2 times 8. So we can write that as 16. We've got an a cubed times an a squared. We keep the base the same and we add the indices together. When we look at the b's, we've got b to the power of 1 and b to the power of 3. Keep the base the same and add the powers together. All divided by 4, a to the 4, b squared. Now again, we'll look at the numbers here first. This we can actually divide. 16 divided by 4. Actually, 4 goes into 16 4 times. So you can work that out. Or you could think of it as cancelling. 4 into that goes 4. 4 into that goes 1. Then we do the a's. We've got a to the power of 5 divided by a to the power of 4. Keep the base the same and subtract the powers. 5 minus 4 is 1. You don't need to write the 1. And then the b's, b, 4 minus 2 is b squared. And that's the end. You can't go any further than that. Let's have a look at these two. These look very complicated. Now in this one, if you have a little look at the numbers before you even start, you could do what I did before and multiply them together here. But you can also see that there's a 5 here and a 5 here. So this is all multiplication. So we can just say that this 5 divided by this 5 will just give us 1. So they effectively cancel. And then we also have a 9 here divided by 9 here. That would also be 1. So it's like they cancel out or they're giving you 1. Now I'm going to go through and simplify the numerator. So we have a to the power of 2 and a to the power of 4, and we're going to add those powers together to get 6. We have b to the power of 7 times b to the power of 2. We add those powers together to get 9. Same on the denominator, a cubed times a squared. Keep the base the same and add the indices. And b to the power of 1 times b to the power of 7 is b to the power of 8. Now we can simplify using the second index law. We've got this bit here, a to the 6 divided by a to the 5 is a to the power of 6. Take away 5 is just a 1. And b to the power of 9 minus 8 is also a 1. And as I said before, you can just write this as a times b. And that's the answer. This one here has got a division sign here. Now, you're being asked to get this fraction and divide it by this fraction. And if you remember what you know about dividing fractions, you have to make this division sign into a multiplication and flip the fraction that follows it upside down, or invert it. We also call it invert or reciprocal. So we are going to rewrite this sum so we can do it. We get 10k to the power of x. It doesn't really matter what these powers are now pronumerals because all the same index laws apply. You just have to be super careful. 8km cubed. We make that into a times sign and we flip the fraction that follows. So 16k divided by 5k to the power of x, m to the power of 2x. Now, let's see if we can do any simplification with the numbers. So we've got a 10 up here and a 5 over here. So I would say 5 divides into 5 once. There's a little 1 there. And 5 divides into 10 twice. So that simplifies. Now we've got this 2 and this 8. So 2 into 2 is 1. And 2 into 8 is going to be 4. And then finally we've got the 4 and the 16, and we can cancel again. So 4 into 4 goes once, and 4 into 16 goes 4 times. So after all of that, you can see that you've just got the 1 times 4 on the numerator here, and a 1 times 1 on the denominator here. And we can write the 1 here, but you don't have to. We'll see what else ends up down the bottom there. We'll write it here just for a moment, because that just shows what you've actually done. Now we're going to go through the numerator and we're going to add the indices, so we have to be careful. Here we've got k, this has got an x, and this has got an unwritten 1. So we're going to add those powers. So we're going to end up with something weird, but we just add them together and we get x plus 1. And there's no other m's there, so it's just m to the power of y. And we do the same on the bottom. So we say we've got k, and here there's a little 1, and we add them up because the bases are the same. We're going to get x plus 1. And on the bottom we've got m as the base, and we add these up. Now they're not like terms, so we just have to leave it as 2x plus 3. Good, now we're nearly there. The 4 is staying the same. This is interesting. We've got k to the x plus 1 divided by k to the x plus 1. Because these things are identical, they're actually going to cancel out. K to the x plus 1 divided by k to the x plus 1 is just 1. And then we just need to try and simplify this. So we've got m as the base. And the second index law says we need to do y minus, and we're going to put it in brackets so we don't muck it up, 2x plus 3. And then the last step is just to expand those brackets. 4my minus 2x, and this minus also applies to this plus 3, minus 3. And it's a funny looking answer, but we followed all the index laws, And so this will be our final answer. And you can see I lost the divided by 1 because you don't actually need to write divided by 1. This example here, this is quite hard. But it just shows you that all the index laws apply no matter what. No matter what sort of indices that they give you. Now, if you want some practice on these sorts of questions, you should go to exercise 6B on page 334 in your textbook. And that is the end of this little video that deals with those sorts of questions. And we're just going to stop the video and I'll do the next one in a minute.